In this section, we are going to discuss Bohr's atomic model. First, we are going to discuss some important theoretical points. Then we will learn the application of the concept through some selected illustrations. So, let us first discuss Bohr's assumptions for hydrogen atom. The first point about the assumptions is electron moves in the circular orbit around the nucleus, which is positively charged under the influence of the attraction force of the nucleus, right? So this is the first point. You can observe here in this diagram, this is the nucleus. Nucleus is having the Ze charge positive, and r is the radius of the rotation of the electron. Electron is having the negative charge. That means required centripetal force is provided by the Coulomb attraction. That is equal to k Ze multiplication E divided by r square. Let us call this radius as Rn. Rn means radius of nth orbit. So this Coulomb force provide the required centripetal force, that is equal to mvn square divided by Rn. Let the equation number 1, right? And second point, only certain electron orbits are stable, right? And these are the orbit in which electron does not emit energy in the form of electromagnetic radiation. That means when electron is orbiting in these stable orbit, electron does not emit any radiation in the form of electromagnetic energy. Okay. That means the energy of the atom remain constant, and classical mechanics can be used to describe the electron motion. That means there is energy constant equation we can apply. Conservation of the energy equation is applied. That means we can use the classical mechanics to describe this type of the motion. And one quantum mechanics term is also used. The size of the alloyed electron orbit is determined by the condition imposed by the electron orbital angular momentum. This is justified by the quantum mechanics, and this is equal to mvr equal to ns divided by 2 pi. If velocity of the electron orbiting in the nth orbit is vn and radius is rn, so here we can write me, that is the mass of the electron. This is the velocity of the electron orbiting in the nth orbit. Rn is the radius of nth orbit, and that is equal to ns divided by 2 pi. And n can take any value 1, 2, 3. Let this equation number 2, right? And this point is justified only through the quantum mechanics. We cannot justify this point using the classical mechanics model. Okay, so let us write equation number 1 and equation number 2 this to the next page. This is equation number 1 and 2. We can observe here Rn and Vn, two constants, and we have the two equations. That means if we solve these two equations, we can find the value of radius of the rotation, that is the radius of the nth orbit, and velocity of the electron also in nth orbit. So from first and second equation, if we solve these two equations separately, we will get the value of Rn equal to this n square h square divided by 4 pi square me k. K is the Coulomb constant, that is equal to 1 divided by 4 pi epsilon naught. Z is the atomic number and E is the charge in electron, right? We can observe here this h is a constant, Planck constant. 4 pi r square is a constant value, me is also constant, k is also constant, and E is also constant. We can write the constant value separately in the bracket like this value. This is n is a variable, that is n is the number of the orbit. Z is also variable, depends on the atomic number, right? That means we can observe here this Rn is proportional to n square divided by z, right? And if we calculate this value after substituting the value of z, pi, me, k and e, we will get this relation, that is Rn equal to 5.29 into 10 to the power minus 11 meter n square divided by z. We can write this term in the angstrom, and we can write here Rn equal to this 0.53 angstrom n square divided by z. N is equal to 1, 2, 3 and so on, right? Now we can write this Rn equal to n square divided by Rn is proportional to, more appropriate, this is proportional to n square divided by z, right? And if n equal to 1 and for the hydrogen atom z equal to 1, we can observe here the radius for n equal to 1 and z equal to 1, say this radius is r naught, and this r naught equal to 0.53 angstrom, right? For the hydrogen atom we know z equal to 1, so Rn equal to 0.53 angstrom, and this value is called the Bohr's radius.